Hello everyone, welcome back. As usual, your cameras, if you can turn on your cameras, could be appreciated. So moving forward, you will be working in your assignment 3. I just want to give you a hint. You're going to have an assignment, and the assignment is going to be due next week. We have this idea with the Pac-man. We review the requirements. We move to a class diagram, quotation mark, and I am trying to connect the class diagram with programming. That is exactly what I am going to ask you to do in an assignment. Requirements, class diagram, programming. So we have this problem, this pseudo Pac-man. And what I want to review with you, what we're doing is not the goal of creating a Pac-man, already exists and you can get it from the internet, but what is the best distribution of classes and responsibilities? How many classes do we need to create something like this that easily can evolve to the Pac-man that you know? We start in the previous lecture and we start with these ideas. You agree with me that it could be good to create a class game. It could be good to have these classes maze, the ghost, the Pac-man, the dots. Just by reviewing the requirements, we agree that these boxes in orange, the names, could be good ideas for classes. We still need to figure out the methods, the variables, how they are going to be connected. But we start with those classes could be good for my problem. It's a good split of responsibilities. Moreover, we talk about libraries. We need to control the Pac-man with the keyboard, exploring options. Java API have some key listeners, things that we can use to control something with the keyboard. So key listener from the library, we need to do a graphical thing, a graphical user interface. We have the JFrame class in Java. Using the JFrame could be something else that we can do. How to use them. Moreover, we go to the details and it's like, well, it's not only the JFrame because it's not only the main window. Probably we're going to need panels, elements, sub-windows inside of the main one. Or we're going to need to draw something, and we do not draw things in the main window. We draw something in a panel, and then we put the panel inside of the main window. That is some knowledge that you get learning about the libraries that you have in the language or the libraries that you have outside. But assuming that you have knowledge of the swing libraries in Java, these ideas of the JFrame, the JPanel, the listeners are there. Moreover, we talk about we need the ghost to move automatically. We need this ghost to be moving without any event from the user. And we come with this idea of, well, there are timers in Java. And basically the timers allow me to use like that, establish a period of time, and every time that timer is enabled, something is going to happen. Maybe I can put a timer for seconds, and the timer is activated, trigger every second some kind of event, and that event could be change the coordinates of the ghost. The class timer is also in the Java API, so I am going to use that class somehow. Inheritance, composition, association, aggregation, I have no idea, but I need the class. Action listeners are going to be related with the timer. We need to review how. So we have all these blue boxes that represent classes from the API, the orange ones, the classes that I am going to create. Moreover, something that we agree and review quickly in the previous lecture is sometimes you need classes that the only reason for they to exist is to be parents of other classes. What is the goal of having one parent for a group of classes? In this particular scenario, having a parent for the Pac-man, the ghost, and the PowerDot. When you put a parent, the goal is establish a hierarchy. When you put a parent, having parents in programming is a very common practice, a very good thing that you can do in your programs is having a parent allow you to implement polymorphic behavior. Having a parent is going to allow us to have this thing like the parent for those three. And then if I need those in game or in the maze, in some place, instead of having 3 diamonds and 3 different things with 3 different classes, the only thing that I do is I am going to need that, the parent. I can have an array of 3 or 6 elements drawable. And in that array, I can put the ghost and the Pac-man together. I am going to ask them to be drawn on the screen. It's one array. All the elements in the array are the same. But because of the polymorphic behavior, they can be replaced for any of the childs of the parent class. So this is the last thing that we review in the previous lecture. Sometimes we use add classes because we need this, the boss of the hierarchy, the root of the tree, a common parent that can be replaced by any of the childs. That is what we have. So reviewing the programming. A key idea with object-oriented is when you read one class, you need to be able to understand in that class one single responsibility. It should be obvious to read the class and understand what are the responsibilities for that class. And if possible, the responsibility should be one. Should be this class is doing this particular thing, nothing else. Working together, this one with others, we're going to achieve a solution for a problem, a bigger problem. But one class, one responsibility. Let's review the Pac-man. We can start with the ghost, the Pac-man, the PowerDot, and the parent, the green class, the drawable. This segment here, we can start with them and later connect with the others. We reviewed this quickly in the previous lecture. Number one, a common parent. Usually, a good practice. Unless that common parent is going to be able to do something special, that usually is not the case, your common parents are going to be interfaces. Help me, what is the difference between an interface and a class? Interface versus a class, what is the difference? Why this one is an interface? The classes have members. Okay, good. Let me put this in this way. In a class, you're going to have attributes, variables. You're going to have methods. The methods are going to have a body, instructions, specific steps about how to solve the task. An interface. The interface, the only thing that you have is the skeleton of a method, the signature of the method, the name of the method with the parameters and the return type, but no body there. An interface, use a name of a method, semicolon. Why they exist? Because any single child, any single class that inherit from this parent, that inherit from this interface, is going to have the responsibility of implementing that method. So in our example, I am creating this method draw in the interface drawable. And the only thing that I am doing is being sure that Pac-man, Ghost, and PowerDot, all of them, they are going to have mandatory a method draw. And I know what are you thinking. It's like, Professor, you do not need the interface. The only thing that you need is to put the specification in some place that the class should have that method. Let's think about it. I have 3 programmers, and I want one programmer doing the ghost, one programmer doing the Pac-man, one programmer doing the power ghost. I want 3 people, each of them working in one of these classes. That is the goal. When you split something in a class, you need to think that that class is going to be doing by one person, different from the one that is going to accomplish the other classes. Remember, it's a big system. We're not doing the house for the dog. So 3 classes, 3 people. What can I do to be sure that they, the 3 of them, are going to remember that I need a method in their classes, and that method is going to have this name with this return type with this parameter? Option number 1, trust that those 3 programmers are going to remember my instructions. Trust that they are going to do what they are told to do. That doesn't work. It is better to say, guys, here is the interface. Copy this file from the repository, download this to your computers, and you're going to do the class Pac-man, implement this interface. You're going to do the class Ghost, implement this interface. You're going to do the PowerDot, implement the interface. And you know what is going to happen? That if they do not implement the interface, one test case, and I return the class to them. One test case is the first instruction, the only one that I give you is to implement the interface. You didn't do it. Easy to test. Second, if they implement the interface, and if they do not provide the method, just like in the format that I am asking, it's not going to compile. The compiler is going to be doing my work. Instead of me checking that you create the method correctly, your program do not compile if you do not put the method that is expected. In that direction, interfaces are like the contract between programmers. You're my programmer. I am giving you this interface. My instruction is implement the interface. If you implement the interface, I am sure that you're going to provide to me the methods that I want with the parameters that I ask, with the return that I ask. Your class is going to have what I need. And therefore, someone else can worry about how to use this because all of them have what we need. A compromise for one part of the system. Okay, so that is the goal of the interfaces, these contracts. My contract for the Pac-man, my contract for the people developing the characters. Use, create elements that have a method drop, that receive as a parameter a graphics, and return nothing. That's it. So with this common parent, one people in the team can create, for instance, the easy one, the class PowerDot. The class PowerDot, mandatory, implement the interface, the connection between the 2 classes, right? The realization. Inside of the class, whatever I need. What I need for the PowerDot, well, something that I am going to need for all my classes is where they are going to be, a coordinate X and Y. You can put any name that you want, but they are variables, integer, and as usual, your variables should be private, hiding information, remember? The goal of a class is to encapsulate the information. The user external should not have access to the information directly, but using public methods, getters, setters, variables, private. So private, X and Y, integers. Usually, your classes, every single class should have a constructor. A constructor is something mandatory in your classes. What is the goal of the constructor? Your constructors, the main responsibility they have, initialize the values for the variables. Initialize values. Using what? You have 2 options. Default constructor, the one that do not receive parameters, and you put default values. Or you have a constructor, the constructor receives parameters, and you use the parameters to initialize the values. Two options. You can use both or only one according with your problem. In this particular scenario, there is no reason for having a PowerDot in a default position. They have particular positions that they are going to be. The easy way to connect this is receiving as a parameter in the constructor the position for the particular PowerDot. I am going to create 4 of these, the corners. I receive the X and Y for them. And what is the constructor going to do? The only thing that a constructor should do. Copy the values that I am receiving to the variables that are global. It's the only thing that you put in a constructor. Provide values to the variables. So far, good. Next, I was required to have this method draw. I need to put that because if not, my program do not compile. And I need to put that because it's in the interface that I am designing. Now, what I receive as a parameter is graphic. Graphic. If you're familiar with Java, graphic is the representation of a canvas in your screen. It's a space in which you can draw something. An object graphic have this method, set color, draw rectangle, draw rect, fill rect, a rectangle fill with one color, draw oval, fill oval, draw line, set color. All those methods already exist in the class graphic. And you know what? My class is receiving as a parameter a graphic. Where is this graphic? Which part of the screen is the graphic? I do not know. It's like you're receiving as a parameter a piece of paper, and you are being requested to draw in that piece of paper the Pac-man, or the ghost, or the PowerDot. I am giving you here, this is the space in which you are going to work. Do your work. Where this is going to end, you don't care. Your responsibility is to work with the tools that you receive, period. What is going to happen later or after is not your problem. Your method draw, I am asking you to draw. Draw what? Well, if this is the class PowerDot, I am asking you to draw the PowerDot, and I am giving you the piece of paper in which you are going to work. The only thing that you need to do is to use that piece of paper, that object, G. Very common in the books and in the tutorials, they use this name, G. You can use whatever name you want, but G is going to be common. In the graphics, number 1, set the color, white. Draw a rectangle, a rect. A rectangle, fill, painted. And parameters. Parameters. The X and Y. The X and Y is the corner at the top in the left of the rectangle. And then the numbers. The numbers, yeah, the white. My class PowerDot, the only thing that it's doing is drawing a rectangle in white. If I want you to draw something more complicated, this is the place in which you can do it. This method draw, instead of being 2 lines, can become as complex as you want it, as complex as you need it. One responsibility. The class PowerDot help me to create objects. PowerDot. A PowerDot have a coordinate, X and Y, a constructor to establish values for those variables, and a method draw. And the method draw the PowerDot in the parameters that I receive, a graphic, a piece of paper. Very simple. Can you imagine the Pac-man or the ghost following the same philosophy? Because the Pac-Man and the Ghost are kind of brothers for this class. This PowerDot, the Pac-Man and the Ghost, they are in the same family. The Pac-Man, following the same idea. My class, Pac-Man, is going to have as a parent drawable. Because have that parent, it is mandatory to implement a method draw that receives as a parameter graphics. That was the reason for the parent. Moreover, following the same idea, the only thing that Pac-Man is going to have is two variables, X and Y, the coordinates of the Pac-Man on the screen. This one, I do not need a constructor for the Pac-Man. I can add it if you want, but I am going to create only one Pac-Man, and I already know the coordinates of that Pac-Man, the center of the screen. And the center of the screen could be 0, 0. And if I think about the coordinate of the screen and 0, 0 being the center, then by default, these variables, the initial value of any variable in Java is 0, 0. I do not really need a constructor, but again, I can add it if you want it. To save space in my slide, I remove the constructor. However, what I need is somehow methods. My variables are private. I need methods, public methods that someone can call to change the value of the position of the Pac-Man. So I create these methods, up, down, left, right. You can use whatever name you want. But the idea is I have those 4 methods. And what they are going to do is increase or decrease the variables. Nothing else. I am Pac-Man, I have X and Y, and I have public methods. So those public methods can be used by someone else to ask me to move up, down, left, right. And basically that means to change the value of my coordinates, X and Y. If I am moving left, right, I am going to change the value of X. If I am going to move up, down, I am going to change the value of my Y position. So Y, X. The method draw, similar to the previous one. The only thing that I am going to have is I receive as a parameter this piece of paper, the graphics, and I can use graphic. You can use G, whatever name. This one is GO, go. Set color. I want the Pac-Man to be yellow. And I am using, again, fill rectangle. I can use fill oval here if you want the Pac-Man to be circular. If you want to draw the mouth or the eye, here is your place to do it. You can complete this with more instructions, with more lines, with more details. The only important thing is I am drawing something in yellow, and these are the coordinates, the one that I have above, the one that I am changing with these methods. And just for the example, the size of the Pac-Man is exactly the same size that I have for the PowerDot. You can change that. You can make here the Pac-Man bigger or the pills smaller, whatever. This is the method to do that. The only thing that I am doing is drawing something in the coordinates that I have as an attribute. Now, something else with the Pac-Man. You know what? The Pac-Man is going to be moving, but I do not want the Pac-Man to move to particular places. For instance, maybe there are obstacles. Maybe there are collisions in the place. Here is the place in which I can check for collisions, maybe. So far, the only thing that I am doing, the only thing that I give you in the source code is these conditions here. What I am doing there? What is happening between the line 11 and 14? It is easy to guess. It's easy to understand what is happening there. Why those conditions there? Ideas? You are moving grid size. Good. You are moving, you are drawing the Pac-Man, and this can happen after or before you move, up to you. But it's basically to review that the Pac-Man do not go out of the screen. The X of the Pac-Man, the Y of the Pac-Man cannot be lower than 0 or greater than 400. Obviously here and here, it is better to use constants. It is better to define some kind of configuration file. It is better to get the size of the screen. There are better things that we can do there. I use 400 and 0 to give you an idea in one slide of what can be done and where. Did you notice for the PowerDot X and Y coordinates, a constructor, I am going to define the value of the coordinates. They are never going to change. And the draw method. For the Pacman X and Y coordinate, I do not really need a constructor. It is better for me to have four methods that help me to increase or decrease the values of the coordinates. And I need a draw method. And the draw method, now yellow instead of white. Same process, manufacturing the classes. You can imagine what is going to happen with the ghost. It's a brother of the previous ones. So for the ghost, same parent. I need X and Y coordinates. And I need the draw. Now, I need the draw, and I am going to draw the ghost. However, also, I need to calculate the position of the ghost. The position of the ghost is not going to be like the PowerDot that is always the same. It's not going to be like the Pacman that I need method to change up, down, left, right. It is going to be this system or artificial intelligence guy that is moving the ghost. It's going to be something smart. For my example with the Pacman, it is going to be random. Random in X, random in Y. The only thing that I am doing from here to here, what you define in the requirements, like the artificial intelligence controlling the ghost. My artificial intelligence is used randomly two numbers, and that is going to be the increment or decrement for the position. As you notice, I defined that my ghost originally is going to be in 400, 400. So like in this corner of the screen, and then it's going to start moving. It's going to start moving randomly here and randomly here, but every time plus minus 20. So 400 plus minus 20, and you can imagine the movement completely random is what we have in the picture. Wait, we need to implement this smarter. We need to implement this in a different way. The ghosts move not randomly, but with some kind of algorithm. This is the place to do that. This is the place to change that. Maybe here, instead of having this code here, I can call a method move. And that method move could be a method in this class. And probably it's going to be a private method because it's a method that you do not call from the external of this class. It's a method that you call inside of the class. And your method move could be your algorithm that implement the calculation of X and Y in a better way that use random numbers. This is the position for that particular part of the program. Moreover, the same thing that I have for the Pacman. Review that the ghosts do not go outside of the screen. Keep the values, even though they are random, greater than 0, lower than 400. Similar code that for the Pacman. Draw the ghost. Fill rectangle in the red color. almost exactly the same code for the dot, the Pac-Man, and the ghost. The special changes, minimum differences, are about the behaviors. One is moving randomly, the other is moving with up, down, left, right, and the other is not moving at all. One responsibility per class. And the most important thing, I do not care where I am going to be draw. If I am the Pac-Man, I am drawing myself where? In graphics. The same the ghost, the same the pill. Each class is independent of anything else happening in the game. Done. I can give you this, and I can ask you to implement more complex behavior for the Pac-Man or for the ghost, and you know where to work. You know which class you're going to modify. Moreover, what happened with the other classes is not your concern. You can work here in this file. That's it. Okay, so far, could be okay. Now, what we have is this done, and this done. That part. Next, the next part is, what do we do to connect the ghost, the Pac-Man, and the PowerDot with the game? Or which is the class that we can use to connect this with this? Because we have kind of these two big parts. One, the elements, the items. The other, the game, the maze, the panel. They are kind of the containers for the other guys. So thinking about common sense, where did you put the ghost, the Pac-Man, and the PowerDot? Moreover, where and what is the relationship to use? Inheritance, composition, aggregation, association. I agree with that idea, the maze. Why the maze? You know what? Just because makes sense. Let me be honest. If you tell me that you want to connect these elements with maze, I will tell you it's a good idea. If you tell me that you want to connect those elements with game directly, I will tell you it's a good idea. Just do the thing that makes sense. Let me be clear. Option number one, this is game. Game is the main window. And you can tell me, you know what? We're going to have the maze. And inside of the maze, we're going to include the Pac-Man, the PowerDot, and the ghost. And then we're going to include the maze in the game. This is what you're telling me. Or you can tell me, no, I prefer to add the maze to the game, and I want to add these guys also directly to the game. The black option and the red option, and you know what? Both can be done. The problem can be solved in both ways. However, if you think about which of the two make more sense, I will agree with the idea of these guys are inside of the maze. They are elements of the maze. Makes sense to add them to the maze. And later the maze, with all these items, add to the big window. It just makes sense. Now, going back to the diagram, we're going to use maze. And instead of connecting maze with the three elements separate, you agree with me, what we need to do is to connect maze with drawable. One connection, only one connection. And what we are doing is Ghost, Pacman, or PowerDot, they are connected with maze because any of the childs can replace the parent. We connect maze with drawables, and we're going to be able to have Ghost and Pacman and PowerDot. One connection, and we have access to all the different possibilities. Okay, one connection. That one connection is going to be what kind of connection? I just draw here a line, but we're going to do aggregation, composition, inheritance, which is the best connection between maze and drawable? The connection that represents what we want. And what we want to have Ghost, Pacman, and PowerDots inside of the maze, right? Which of the relationships in the class diagram help me to represent that? Having these guys inside of this guy. We have two options, composition and aggregation. The diamonds, is going to be a diamond involved. There is no other answer. It's going to be a diamond involved. There is going to be a diamond in maze because we want the other elements to be inside of maze. We want the other elements to be variables inside of the class maze. That is what is going to happen. The decision that we need to take here is the diamond in black or the diamond in white. It's going to be mandatory for the maze to have the other elements, or it's going to be optional. Ideas. The relationship between maze and the other guys is like the relationship between the car and the wheels, or is like the relationship of the car and the engine. That is basically the question. Can the maze exist without the Ghost, the Pac-Man, and the pills? And hopefully you agree with me. Yeah, the maze can exist. It's like the car can exist without the wheels. So following your answer, it's going to be a diamond. It's going to be a white diamond. Easy, right? Okay, the maze. What I need to do is to program this relationship. Moreover, program the relationship and put in maze whatever is the source code for maze. What do you think about this solution? Let's see. Maze. Extend JPanel. You are extending maze from JPanel. So you are doing here inheritance. Notice the difference between inheritance and implement. The solid line or not. Why are you doing maze extend a JPanel? One particular reason, the maze is going to draw something, and it's going to draw something in a panel. Our maze is really a panel in which we're going to put the graphical elements. The advantage of doing inheritance from panel is basically one thing. We are going to have access to this method. When you do inheritance from panel, you are inheriting a method paint component. All the panels have a method paint component. Moreover, that method receives as a parameter the space in the panel in which you can draw. Who is going to call the method paint component? I don't care, but someone is going to call this method. Someone is going to give me this object G, and I can work with that object G. We're going to review that paint component. Now, moreover, I need variables and I need a constructor. My variables, what do I have there? An array. private. The array is going to have three items, drawable. I just want to be sure that you remember. You're going to have an array, 3 elements. These 3 elements are objects. And those objects can be drawable, ghost, Pac-man, or PowerDot, polymorphic behavior. I'm going to have these items, 3, and I am going to use my constructor to initialize the values for that variable. My constructor, you know what? I am going to have a constructor, and this constructor is going to initialize the elements 0, 1, and 2. I have an array, right? So elements 0, 1, and 2. And what I am going to do in this case is I am going to use only one of each of them. If you want to create a Pac-man, you can do more ghosts and more PowerDots. I'm just showing you an example with one of each. One of each. PowerDot. For the PowerDot, the maze, I can create my PowerDots here. I can just take one of the elements in the array, and I can say that that element in the array is equal to a new PowerDot. Notice here the polymorphic thing. The item 2 is drawable, and I am making equal to PowerDot, the parent, the child. And I am doing this equal PowerDot, and I am creating a PowerDot in these coordinates. So my PowerDot, my Y rectangle, is going to be in the coordinate 330. That is going to be the coordinate for the white PowerDot. And it's never going to move, according with what we read in the previous class. What happened with the Pac-man and the ghost? I can create a Pac-man and a ghost here, but also I can receive as a parameters the Pac-man and the ghost. You reviewed this in 110. Values, you can put the value here, or you can receive the value as a parameter. There is one particular reason because I am sending the values as a parameters. I am going to explain later, but item 0 is this Pac-man here that is from the class Pac-man. Item 1 is this ghost here that is from the class ghost. So I have an array of drawables, but really what I have is one of each of the categories that I define. The maze, values for the variable, an array of items. Tell me, this is really a white diamond or not? Because remember, the class diagram and the source code should match. I put a white diamond here. Is fine with this? Yes. Why yes? For the PowerDot, is no, because I am creating the PowerDot there. For the ghost and the Pac-man, just because I do not have the news there, I do not have the news here or here, they can be null. Let me be clear. This here, this new, is creating the array. But remember that in Java, what I am creating with this new is the 3 elements of the array. But they, by definition, they are null. This new here is creating an array with 3 null objects. That is the reason because later here, when I do the new, I am creating this object. What happened with the other 2? The other 2 are going to be this ghost and this Pac-man. Whether or not they exist, I do not know. Reading this class, only reading this class, I cannot be sure that this Pac-man and ghost that I am going to receive as a parameters are going to be different from null. Just reading this class, I cannot sign that they are different from null, because this code is not telling me that they are different from null. Therefore, I need to assume that they can be null, and if they can be null, the diamond should be white. So white diamond, yeah, white diamond. I cannot tell you that for sure they are going to be different from null, all of them. So I need to put the diamond in white. Only if I am sure that they are not null always, like the engine with the car, then I put the diamond in black. It is not the case here. So far, I have my variables and I have values in my variables. Next step, the paint component. The method that I am inheriting from JPanel. The method that is going to be called every time that the window is going to be drawn. And what I have inside is very simple. Number one, every single time that you are going to override a method paint component, is a very good practice to do this. Can you tell me what I am doing there? What is that super there? Do you remember? Super in Java. You are calling, yes, you are calling the constructor for the parent. This super here is calling the constructor of JPanel. You are going to override the paint component method. Is a good practice. Always, always, always. The first line inside of your paint component is to call from the parent the same method paint component. So super, the parent, dot paint component. Why? Because inside of a panel, you can put more things. What you are going to do is to draw this panel, but you call the paint from the parents to be sure that every single thing inside of that panel is going to be drawn. What happens if that panel have something outside, a name, a border? You call the panel is going to take care of that part. And whatever you do here is the thing that you have inside of the panel. Use a good practice in programming to avoid missing elements. First line in your paint component, call the paint component of the panel. So we are sure that both are working. And after that, your work. Your work. What I am doing there? What is happening from the line 14? Well, the line 12 until the 22. By now, you are familiar with the G dot. G dot drawing in this piece of paper. What I am drawing here. Hopefully you notice I am changing the color. Now I am going to use gray color. Then I am drawing a rectangle. If you notice, the rectangle is going to go from 0 to 500. So it's going to be a rectangle that is going to cover all the screen. It's going to be just a big border for the screen, for the panel. And then I have this for loop, and the for loops are drawing lines. So I am drawing a big square, and then I am drawing lines, and lines. I draw a grid. Okay, from 14 to 19, I draw a grid. What is happening in 20 and 21? 2021 is a for loop. The for loop from 0 to the number of items in this array here. Well, my walls are this grid. It's like this grid is the wall of my mesh. Remember, we're not full doing the Pac-man. So these are my walls, the grid. But in that lines 20 to 21, did you notice that this 0 to 2? I am going to run that loop for the values 0, 1, and 2. 0 to the size of this variable here. I am going to run something for each of the elements in the array that I have as a variable in the line 5. Exactly. For each of the items that I have, I am going to call the method draw. Are you sure that your items in that array have the method draw? Yes, I am sure, because the array is from the class drawable, the interface drawable. And every single implementation of the class drawable have a method draw. So I am sure that I can create a loop, and inside of that loop, I am sure that I can call the method draw for every single element that is in this array, because in order to be in that array, you should be a drawable object or an object that is a child of the drawable interface. So yeah, I am sure that there is a method draw in whatever element in the array. In particular, in the array, what I have is one PowerDot, one Ghost, one Pacman. So if I want 4 PowerDots, and if I want 4 Pacmans, the only thing that I need to do is to make this array, instead of 3, 9. And in the constructor here, instead of adding 1, I could add 4 Ghosts, and here 4 PowerDots, and that's it. They are going to be drawn. Yeah. The only thing that you need to do is to create more objects, and the objects have the method draw, and they are going to be drawn according with the coordinates that you provide. When you visualize the thing, I do have Pacman, PowerDot, and the Ghost, and the classes in which I define them, they do particular specific things that are easy to understand. When I come here and read the class for the maze, hopefully it is also easy to understand that the maze have an array of drawables that can be any of them. A paint component, that is the new thing because I am using panel, and the constructor to provide values. That's it. Important part, that variable, that is my diamond. Okay, so far good. I have the maze, even though it's just some lines. This is the part that you can change to create the walls in the maze in a more interesting way. But this is the source code that will change. Everything else is the same. Okay, you have the elements, you have the maze, but still we do not have the main. We do not have the full program. We need to complete the connection between the maze and the game. We need to connect these guys. What could be the connection? What should be the connection between game and maze? Hopefully you agree that they should be connected. Could you agree in a diamond? And hopefully you agree that the diamond should be together with game, not to maze. Game is going to have a maze. Composition association is your choice. You can create the story in both ways. For this particular scenario, my suggestion could be black, just because I am trying to tell you that the game cannot exist without the maze. I cannot call something a Pac-Man video game if I do not have at least on the screen the maze, in this case, the grid. So just because of that, I could suggest the black diamond, and therefore that is going to impact the programming. But my point is a diamond. We're talking about composition or association, my recommendation for composition. Now, do you remember that we pass as a parameters the ghost and the Pac-man to the maze? The maze have these drawables. We create the PowerDot. We put the new of the PowerDot in the class maze. But the ghost and the Pac-man, we pass as a parameters. Think about this. One of your friends borrow you a computer. You have a computer. You receive the computer. You can use the computer because you have it. You have it, but it's because you received that from someone else. The owner of that computer is someone else. So theoretically, you have it, but the owner, the first one to have it, was another person. It's the same computer, but somehow two people that have ownership for that. If I am thinking about passing as a parameters to the maze, the ghost, and the Pac-man, I am going to send them as a parameters. Who can send them as a parameters? According with these connections, the only one that can do that is game. Can you agree that we can ask game to create a maze, and game is the one that is going to send these parameters? Maze, here. This is a ghost, this is a Pac-man. Put these two guys inside of you. And where they come from? One of your friends is going to borrow you a laptop. The laptop should be created in some place. The laptop should be bought in some place. Something that I am going to do is, you know what? This guy, the game, is going to be the owner of a ghost. And this guy, the game, is going to be the owner of a Pac-man. The game is the owner. I am going to show you the code. I am the game. I have the ghost. I have the Pac-man. And I am going to have the maze. And my Pac-man and my ghost, I am going to pass these two guys as a parameters to the maze. And the maze is going to have it. They are going to be inside. The maze is going to be able to do whatever they want with them. But I am the original owner. That relationship is, there is a diamond between game, ghost, and Pac-man. There is a diamond between the maze and the drawable. That later can be the ghost and the Pac-man. Makes sense? And you should be thinking like, why? Why do we need these two diamonds or these two relationships, two classes connected with these guys, the ghost and the Pac-man? There is one important reason. For the Pac-man needs to be moved with the keys of the keyboard. And who is going to be listening to the keys in the keyboard? Hopefully you agree with me. Game. Game is the one that is going to have information about the keyboard. And therefore, game is going to modify the position of the Pac-man. Game is going to do that. However, maze have also access to the Pac-man. Maze is going to be drawing the Pac-man. Drawing the Pac-man in which position? In the positions that come from the keyboard. I need you to think and remember that what we're going to have is this idea of an object Pac-man. The object is going to have these variables X and Y. We're going to have this object game. Somehow game have a reference to the object Pac-man. This game is going to be using this reference to change these values. And we have another object, maze. And this maze is going to be calling the draw method. And this maze is going to be drawing the Pac-man in whatever numbers are here and the numbers come from this game. So we have two objects connected with one, the game and the maze connected with the Pac-Man. One changing the numbers, the other drawing the circle in those numbers. In terms of the class diagram, one is the owner to change the values. The other is an aggregation to be able to draw. Show me the code, okay, the source code. Two slides, part 1. Class game. And hopefully you can be thinking right now about the class diagram. Try to visualize the class diagram of this and be sure that you agree with me that there is one and only one correct class diagram that is equivalent to this source code. Class game. Extends JFrame is going to be a window. Implements action listener and key listener. Can you create the class diagram equivalent to the line 7? Question in your exam. Line 7, use the line 7. Give me the class diagram. Game, JFrame, inheritance, like this, the listeners, can you agree with that picture? Moreover, can you put the names in each of the boxes? Hopefully, yes. If not, it's the time to ask. So far, so good? Line number 7, the class diagram, something like that. Yes? Okay, one yes, good. At least someone is, thank you. Okay, moving forward. Three variables. Maze, Pac-Man, and Ghost. The maze, the Pac-Man, and the Ghost. They are connected with game. And hopefully you agree with me, just because I have these attributes, variables in the lines 9, 10, and 11. Diamond, 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 diamond. At this point, just reading 9, 10, and 11, if I just read those, they are white diamond, because there is no new instruction in 9, 10, and 11. Again, just reading those lines, the only information that I have, if I am reading top down, is they are diamonds because they are variables. So far, I could assume that the diamonds are white, so far, because I haven't read any other thing. Now I continue reading line 13, 14, 15, and what I have is a constructor. Moreover, a default constructor. The default constructor is always executed, right? Default constructor. I am going to show you the main later, and we're going to call this constructor, but this is the default. And what I have here is new. Every single time that I create an object game, this constructor is going to run. I do not have any other. And the constructor is going to run the new for the variables that I have in the lines 9, 10, and 11. Should the diamonds be black or white? Now that I read the constructor. Hopefully everyone agree with the chat. Black. Why? I read the variables. There is no new in the variables. I put the diamonds. They are attributes. They are going to be diamonds. My first assumption, white, because I do not have news. Continue reading, constructor. There is only one constructor. It's the default constructor. I have news for all the variables there. Not for one, like before with the PowerDot, for all of them. And they are separate relationships. So for each relationship, I have a new. For each white diamond, I have a new. Therefore, the white diamond becomes black. It's mandatory. There is no way to create a game without creating at the same time the Pac-Man, the ghost, and the maze. And therefore, the relationship is composition instead of aggregation. So, done. And here, I am passing the parameters, remember? I am the owner of the ghost, I am the owner of the Pac-Man, but I am going to send my Pac-Man and my ghost to the maze so the maze can do their work. I create them and I use them as a parameters for the other guy. So far, so good. Next. What I am doing there. Here, I am playing with the API of Java. The only thing that I am doing is telling the frame, the window, that in the main area of the window, the area at the center, I am going to add maze. And you remember, maze is a panel. So basically what I am doing is adding the panel with the maze to the window. This is the point in which I am having this window. I am adding inside of the window the panel in which I have the grid and in which I put also my ghost, my Pac-Man, and my PowerDot. So this line is connecting everything. And one more thing for the frame, add a listener. Which listener? A key listener. What is going to happen when a key is pressed? Call a method in this class. And I am going to show you the method below, but key listeners. I am adding a key listener to the main window. Something is going to happen in the main window with the key listener. Okay, so far the constructor provide initial values and assembly everything. That is what a constructor do. Next, I have this method. This method, the only thing that method is doing is from the class timer, an object with a new timer, 2 parameters for the timer. The timer is an object from the library. So I am using the library, using a class from the library, call it timer, in the same way that you can use panel or JBottom, JLabel, whatever, is a library. I am creating an object from that class, and that object receives parameters. The parameters that I need to send is the delay, the period of times, and an object. Every 100 milliseconds, this object is like a clock, and it's going to be counting 0 to 100. And every time that reach 100, it's going to send a call to a method in this class. This class. Notice that I have this and this. In the same class, I am going to be calling a particular method for the keys and a particular method when this timer ends the counting of 0 to 100. 2 things that are going to happen. Question here. I am using timer. Timer is a class from the library, and I am creating an object here inside of a method. It's a local variable. And then I am using timer, the variable, to run a method start. Start is a method inside of the class timer that I am calling with the object. So there is a relationship between game and timer. Do you agree with that? And my next question could be, which kind of relationship? And I have the answer on the screen, association. Do you agree? Because if the relationship is association, I do not have diamonds. So do I have diamonds between game and timer? Yes or no? Question in your exam. You can be thinking like, yes, you have diamonds because you have the new. But the answer is no, because the new is a local variable. not a global. The new that you have in the constructor is for the global variables, not for the locals. So game and timer, association, pointing from game to timer, because game is the one that is going to call the method, and the method is in timer. Black diamond, black diamond, black diamond, white diamond, realization, 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 inheritance, realization, inheritance, realization. Our class diagram, you stay shape. Good. So far, done with the first part. Let's review the second part of the game. Second part of the game in 1 minute. Number one, method, action, perform. You know this guy. This guy is connected with the interface, this action listener. Who is going to call this method, action, perform? Who is using the action listener? Because usually we use the action listener with click in something or select something. But here I do not have any graphical element that do that. Who is going to call the action perform? I have two options. The timer and the key listener. You know what? The timer. Every 100 milliseconds, timer is going to call action perform. Every 100 milliseconds. And the only thing that I am going to do every 100 milliseconds is to ask the maze to repaint. Wait. You are using a timer to repaint the screen, and you are repainting everything, the maze? Yeah, because repainting the maze is going to repaint the ghost in a new position, and if I move the Pac-Man with the keys, it's going to repaint the Pac-Man also. I use 100, but you can go to 60 or 30, and it's the number of frames per second that you want to have in your game, period. When you press the keys, you are changing the values of the variables. When you calculate the new position for the ghost, you are changing the values in the variables. They are not being painted immediately. You paint them every 100 milliseconds. In my case, you can select 60 or 30. That's it. The frames per second. Or you can change to 240. You really do not need 30, 60, or 100 for the Pac-Man. It's not that kind of game. So yeah, I could agree with it. Could be better the 200 or something like that. You notice in the picture that I show you, it's like creepy, the movement of the ghost, like shaking. So moving to 200 could be better, smooth movement, right? Anyway, the other one is this one. Who is calling key release? The key listener. Every time that you press a key, this method is called. And this method is called, and well, one thing that I receive as a parameter is which key I press. And the only keys that I am interested in are this one, this one, this one, and this one. And those are the names in Java of the keys with the arrows up, down, left, right. And the only thing that I am going to do is to use my object, Pac-man. Do you remember? I have this object here. It's global, so I can use the object here. And I am going to call the methods up, down, left, right. So the only thing that I'm going to do is I am listening the events in the keyboard. When I receive an event, I am going to call a method in the Pacman to notify the Pacman this is happening. The key up, the key down, the key left, right? This is happening. What do you do with that information is your problem. What the Pacman is going to do is increase and decrease the variables, right? That's it. I need to override also these methods for the key listener, even though they do not have anything. But if you do not put them, your program is not going to compile because that is part of the contract for the key listener. So you have those methods there empty. And the last part, the main. The main, call the constructor that is going to create everything, the size of the screen, the size of the window, make the window visible, enable the red circle or the X in window to be able to close the window, and call my method start timer. The method start timer, yeah, this one, the one in which I create the timer, the one in which I start the timer. With this source code, you have this class diagram, and with this class diagram, you have the functionality that I showed you before with the picture. My homework for you guys, please review the source code. If you are able to do it, copy paste, transcribe the source code, they are pictures, run the code. Be sure that you understand what is happening. Moreover, be sure that you understand every single line relationship in this class diagram, now like a class diagram, and in relationship with the source code. Any question for today? Okay, guys, see you next lecture. Thank you.